This is a special conference for me. This is a conference I could actually travel to by bike, which is very different from last year when I had to fly all the way to SF. I'd like to take you on a little bit of a journey or exploration on the topic of namespacing. And we're here to celebrate 10 years of GraphQL. That's a very festive occasion. And what's interesting, sort of looking back, is that we've also gone 10 years without namespacing. Is that a good thing? Has it held us back? Is there something missing? The topic of namespacing has come up repeatedly over the years. And actually, this is one of the oldest issues on the spec repository. And when you look back at this issue, what's interesting is that it's not just almost 10 years old, but it's also an issue that has generated a lot of discussion over the years. The discussion keeps sort of coming back. The last comment is like just a few months ago. So this is definitely a topic that's still on people's minds. But when I sort of went over this discussion and some other conversations, the thing that stood out to me is that there are actually a lot of different things that people expect to get out of namespacing. I don't really think it's a single thing. So the first thing you should ask yourself is, like, why do people actually think they need namespacing? And sort of at a very general level, what usually comes up is something like, we want to avoid naming collisions, which is, I mean, an argument for namespacing in many languages. But when you take a step back and ask yourself, like, where those naming collisions come from, and whether namespacing is really the right solution for dealing with those naming collisions, the story becomes a lot less clear. So I'd like to take a step back first and think a bit about our goals with GraphQL. So GraphQL, as we all know, has been sort of designed to empower API consumers. That's its reason for being. That's why it was developed. There are many other API technologies. The strengths of GraphQL are that it really allows clients to specify their data needs in a language that makes sense to them. And the way this has been described in the GraphQL specification from the moment it was open sourced is in terms of the design principle of being product-centric. So GraphQL is unapologetically driven by the requirements of views and the front-end engineers that write them. I think that's actually a really interesting sentence that we may want to revisit or think about as we start thinking about other API consumers beyond the views and the front ends. So that's something I sort of want you to keep in the back of your mind. We're not just talking about traditional UI components. We're talking about perhaps a new class of API consumers, agents of agentic systems. But the idea here is that GraphQL starts with the sort of the way of thinking of these front-end engineers, or at least the API consumers, and then builds the language and the runtime to enable that. So the starting point is always like, what do we actually want API consumers to be able to do? And obviously, that's where you get to the query language. And I still think sort of the experience of opening graphical, typing a query, getting back results, that's pretty magical, especially if you come from other API technologies. Because in one query, you're able to get sort of exactly the data you need for a particular piece of your UI or a particular workflow. In this case, you have all your reviews, you have some author information, some product information, including whether a particular product is in stock. So how does GraphQL actually enable a query like this? If this is sort of what we want to get out of the system, what do we need to do to enable this? And here I think there is a pretty big difference between sort of the original environment in which GraphQL was developed and the way GraphQL is used in most organizations today. So as we heard yesterday in Jordan's talk about GraphQL at Meta, Facebook, GraphQL there was sort of designed as a very thin facade. It's really a very thin layer on top of an existing data layer, a graph-like data layer that they'd already developed, which means that sort of the hard work of integrating all those different data sources, connecting them, coming up with a common language, all that work had already been done by the time they developed GraphQL. And I think that shows in sort of the way GraphQL defines its execution semantics, for instance. Like the whole resolver-based model works really well when you have an existing graph-like data layer. It becomes a lot more complicated when you have a variety of data sources and needs for orchestration and translation. And that's the situation at most other organizations. So that has turned GraphQL into more of an API orchestration layer. That's what we've seen over the last 10 years. And that means there's a huge variety of APIs in an organization usually. And of course, organizations differ in sort of the scale at which they operate and sort of how they break up their services. But some of our customers have thousands of APIs. And they want to integrate all of these APIs because that data and those services are valuable for the apps they're building. But if you're thinking about these different APIs representing sort of different aspects of the data and services in your organization, like who should be responsible for actually like orchestrating those API calls and unifying or translating results? There might be naming differences, differences in how entities are identified across APIs. So to satisfy like a query where you want to get like a product and you want to know whether the product is in stock, you may have to go to the product catalog first, get some basic information, including some kind of identifier that you then pass to the inventory system. And all that work has to happen somewhere. And it happens outside of GraphQL. So it's part of the implementation of a GraphQL server, perhaps, of R. But it's not part of GraphQL itself. And in the early days, people tried to write that orchestration code in a monolithic schema. They wrote a single GraphQL server that called into all those different APIs, orchestrated calls across them. But that isn't really a great fit for the organization model of most organizations. There are many sort of semi-autonomous teams at work. They all have their own development workflow, their own pace. So what quickly happened was all those teams started sort of developing their own GraphQL servers. And some of them were sort of better coordinated than others. But in all cases, there were discrepancies between those different APIs. And there were questions around sort of how you could expose all those different services in a unified way. And from the perspective of namespacing, what's interesting, also reading back like those issues, is that people's initial thought was often, let's just namespace by service or by team. So our GraphQL API may expose like, a number of types. We don't want to get into a situation where different systems try to expose types with the same name. So instead, we'll just prefix every name with some kind of service identifier. And there's many reasons why that's not a good idea. But one of them is pretty basic, and that's that a graph doesn't just consist of isolated types. So when you think about sort of a schema that would underlie the initial query I showed, like people's thought here was that they could sort of separate the user type and the product type and the review type. But these types actually span services. If you really look at sort of where the data for each of these fields would come from, you actually have to think not just about a type exposing its own data, but also extending types that live in other services, or at least that aren't part of sort of the core domain that they represent, because a graph API, so the value of a graph API lies in its connections. You want to be able to go from your user to your reviews. That connection conceptually is not part of your account system. It's part of your reviews system. So this already shows that namespacing by type isn't really an option. If you want to sort of namespace by concern or by service, you have to namespace types and fields. So in this case, for instance, the reviews field here, even though it sort of lives on the user type, it's part of the review system. So if you're thinking about namespacing, that field should be namespaced in addition to the type. In Federation, this has led to a model where we break up a graph not by type, but we think about subsets of the entire schema. Each subgraph defines a subset of types and fields. And that includes fields that extend other types conceptually. But what's also important is that a subgraph it has its external view. It sort of shows how data connects to the overall schema. But it also has an implementation. And as part of that implementation, we translate a number of underlying APIs into that common schema. So the task of a subgraph is to act as an abstraction boundary, you might say. Your clients shouldn't have to care about the different data formats or APIs underlying the query they send. So subgraph boundaries should not be exposed to clients. That's a strong stance that we've taken with Federation. If there's a product catalog and an inventory service and they both sort of expose fields on a product type, the client shouldn't have to know where that data comes from. And more generally, I would say a strong design principle is that namespacing should not be used as an excuse to avoid schema design. If you're using namespacing to avoid coordinating with other teams, unifying concepts, coming up with a common language, then you're doing your API consumers a disservice. At the same time, an overemphasis on schema design can also become an organizational bottleneck. That's something we've seen happen, especially at scale, because schema design can become a bit of a burden on an organization. There's a very strong feeling that schema design has to be done right, which is a good thing, but also means that people tend to get sort of risk averse. Every sort of field you add to your schema adds a sort of backwards compatibility burden. And I would say that sort of that overemphasis on schema design, on getting things right and building sort of that one true schema, actually hurts API consumers in many organizations. And that's something that I sort of found tough to accept, because I'm a strong believer in schema design. I really think like one of the main benefits of GraphQL is that it allows you to present a unified view of your data and services. So you should spend time on domain modeling, on schema design, but that can go sort of too far and hold organizations back. And you see that for sort of the kind of questions that that have been sort of emphasized when thinking about federated GraphQL. The questions are all around sort of how to coordinate schema design and how do you keep teams from breaking the API. So it's very sort of risk averse. You have to coordinate. You have to get things right. And I sometimes get the feeling that we're not really paying enough attention to sort of the original design goals of GraphQL, what made GraphQL so great in the first place. We're here to empower API consumers. And if that isn't working with the model we've adopted, maybe it's time to make some changes. So it's a very seductive ideal. And I myself have definitely been guilty of this. And I think many developers sort of have the same feeling. They want to get things right this time. Like you inherit a mess of like many APIs and data formats that have been developed over the years, and now GraphQL is this opportunity to make things right for once and for all. And I would say that that is a seductive ideal, and it's good as an ideal, but the reality is that most organizations don't really, aren't in a great shape to get to that position. And it's also maybe not a very good idea to try to nail things down for not just today, but also tomorrow and a year after. And there are many sort of methodologies and ways of thinking about enterprise integration in general. This is one sort of book that a lot of people have read and have adopted. And I think what's great about sort of this methodology is that it really emphasizes finding a common language and the value of domain modeling, but at the same time, it warns you against sort of trying to build that one true schema. So one of the concepts that comes out of sort of this way of thinking is the notion of a bounded context. So the idea is that you break up your organizational system into smaller parts that, and within each part, within each bounded context, there are a lot of interdependencies. There is a common language, but across bounded contexts, dependencies are a lot looser. You don't try to unify things across those contexts necessarily. And I think this is an opportunity for namespacing. So when you think about federation today, basically, like every subgraph is developed in the context of the overall graph. You have your one graph within your organization, and every subgraph contributes to it, but also every subgraph may depend on types and fields in other subgraphs. So it's very tightly coupled, and dependencies are all sort of implicit. And I think namespaces here offer an opportunity to function as what you might call a coordination domain. I'm not sure if that's exactly the same as a bounded context. I think a graph or a graph API will always lead to a system that's sort of more integrated. But when you think about composition in federation, for instance, like the validation rules that decide sort of which subgraphs can compose together, those very strict validation rules, I think you'd only want to apply within a coordination domain. And you perhaps want workflows that specify sort of who's able to add to which namespace. So maybe there's a core domain that like a platform team is responsible for. You don't want anyone to just add like an unnamespaced field to a core type like user. But you still want people to be able to add fields to user under their own namespace with no opportunity for name clashes. So I think the notion of a coordination domain here is a fruitful one. And when you then think about sort of what that could look like in syntax, I keep sort of going back to the notion of extending types, because I think like in SDL that's a pretty sort of under-specified notion. It's a very sort of, it has some like syntactic use, but I think it like the semantics are interesting. So what I would say here is we have like a part of our schema we're defining under our own namespace, like the MyStore namespace. Our order type lives under that namespace. Our fields all live under that namespace. But I can also refer to types in another namespace. And I can extend types in another namespace. So what this would do is it would extend an invoice type in a Stripe namespace with an order field or a has shipped field. And those fields will not interfere with other fields that live on those Stripe types. So as those APIs evolve, there's no opportunity for name clashes. This is all sort of isolated in our own namespace. And this is a sort of particularly clear example because it's a third-party dependency. But the same sort of principle applies within an organization. Again, if you have some kind of core domain and you have sort of subdomains or perhaps even like product specific namespaces, those can all sort of contribute to the same graph, but because every type and field is namespaced, there's no opportunity for name clashes. An interesting question here is like what does the implementation of these fields actually look like? Because within GraphQL, like the schema is the external view, but how that schema gets implemented, like how each field gets resolved, is something that you'll only find in code. And I think this is also an opportunity to explore other ways in which schemas can actually specify their implementation in a more declarative way. So for instance, here we have our Stripe invoice. The idea is we have our own order type and we refer to a Stripe invoice, but where does that invoice come from? Well, you can imagine some kind of Stripe invoice ID being part of your local schema, and then you define how that ID gets turned into a reference to a type in another namespace. In this case, like invoice is interpreted as a Stripe invoice, but you can also sort of build on that or use other types of expressions to specify how fields would get interpreted. In this case, there's like a country field, and that actually gets fulfilled sort of by traversing into the Stripe API as a client. Like you don't need to know where that data comes from. The implementation might change over time, but this gives you a very lightweight way of specifying these dependencies between namespaces in a way that's easy to evolve. Another use case for sort of these types of expressions is backwards compatibility. Like if you rename a type or change sort of the format of a type of a field, then currently, like at least one subgraph in your system will have to be able to resolve that field. So if you're even if it's just a simple rename, that adds to the maintenance burden of that subgraph. And this will give you a very simple way to specify name changes, simple type conversions. And then I think there's an opportunity to take this sort of even further. And I'm not sure how we're doing on time, but it would be interesting to hear what the audience thinks of some of these things. So I'm hoping to leave some time for questions. But the idea I want to get across is that I don't believe schema design as sort of something that you have to get right for today, for tomorrow, for next month, but also for every possible type of client is a viable model. It works within sort of constrained domains. It works when you have a very disciplined organization, when you have a monolithic code base, for instance. But it's something that in many cases breaks down. And I would really like us to explore the idea of separating the notion of a graph, sort of the abstract collection of all data and services that are available, from the schema. So right now, the idea is that a client, if it's talking to our GraphQL API, like there's a single schema, it contains all the types and fields. I think namespaces are one opportunity where clients can have explicit dependencies on part of the schema. So for instance, you can have a more experimental slice of your schema, or maybe something that's specific to an app or to a product. And a client can specify a dependency on that slice of the schema. And that means that dependency doesn't spread beyond that client. You don't necessarily have to keep sort of full backwards compatibility for those slices if it's only a known set of clients that's using it. There might even be an opportunity for versioning there, which I know is a controversial topic, but I think this might actually be a mechanism that would give us that. So if you use namespacing, you have a way of slicing up your schema, and those slices can then evolve more or less independently. And I want to leave you with sort of an even more speculative thought, which is that so far we've been talking about GraphQL as an orchestration layer. And that orchestration, in many cases, sort of lives in code. It's the implementation of your GraphQL servers, of your subgraphs, that's actually performing the orchestration of like underlying API calls, transforming results, merging results in some cases, orchestrating calls across multiple services. I actually think it's a shame we leave that to imperative code, that you have to write a GraphQL server in order to get that orchestration behavior. And I think there's an opportunity to turn GraphQL into more of an orchestration language. And I've shown some examples of that. I think one area that might be interesting to consider as well is that there's a very nice sort of parallel between the schema and the query. And in current GraphQL, like most of the power lives in the schema. So when you think about adding these types of dependent fields, like something like knowing whether a product is in stock by talking to an inventory system, the natural place for that would be the schema. But not all of that would have to live in a schema. And especially when we start thinking about other API consumers, like more one-off MCP tools, for instance, it can be very valuable to use those same types of expressions in a query. Like you don't necessarily have to put everything in the schema, but you might move things over if you find there's sort of a broader opportunity for reuse. But I think this would give us a very nice way of incrementally building up the surface that an API consumer needs without getting stuck in sort of schema design mode. All right. I realized that was a lot. I'm not sure how we're doing on time, but I think we have some time for questions.
What is the query side? I'm pretty loud, but okay.
Yeah.
What is the query side of your namespacing example look like? So, I mean, I guess maybe you touched on it a little bit in that last slide, but I'm just curious, if you have these namespaces and these different like kind of graphs, right? Like, how would you query them differently? What are your thoughts there?
So I think there's a few stages to that, and I think it's important to differentiate between sort of the local prefix you use and what that maps to, and that's true both of schemas and queries. Once you've set up that association, like an association between like a Stripe prefix and some globally unique namespace representing the Stripe API, within your query, you could either query that API as it's connected to types you also have access to, or sort of depending on how sort of what the relationship is between the two APIs, you may actually want to add those fields or fields sort of as a facade to that API to your underlying schema.
How do you see that dovetailing with, like, what do you guys call them, contexts?
Contracts. Yeah.
Contracts.
Yeah, I would say contracts are a sort of an early version of the idea of sort of exposing multiple schemas, but all it really offers is subsetting. So it allows you to sort of filter out fields that should not be part of a particular view of your schema. But I think what this would allow you to do is sort of it's a much more fine-grained way of very different perspectives. Like for instance, if you have if you're just showing like reviews and you want to know whether a product is in stock, there's no need to like know the details of the inventory system. But if you're building like an admin screen for someone keeping track of the inventory, you need a different view. And that view should be, I mean, they shouldn't necessarily interfere. Like you shouldn't feel a pressure to sort of build the one common schema that all those use cases can take advantage of. Any more questions?
I think I had a similar on the query specifically, but in your example where you defined like has shipped as an extension to the invoice that was part of the Stripe namespace, but you were in your my namespace or your own one. So, but what does that look like from the query side? If you query for has shipped, do you say on the client side, I want it from this namespace versus the other? How does it work that there's no name collisions from the query side?
I mean, all of this is like under development. I mean, these are all things I'd like to have us discuss, and there are different solutions, I think. There's always the opportunity to use sort of explicit namespaces in queries as you're querying fields. You might have some simple rules that sort of decide what the default namespace is at a certain place in your selection set. So for instance, you might start out with, in this case, like your My Store API, but as you go into like a Stripe invoice, maybe the default namespace then becomes Stripe. But that does mean you would need to disambiguate like the fields you've added. And there may be other opportunities here to sort of selectively import fields, or at least namespaces, and have those sort of be merged. But you still want I think the meaning of a query to be statically known, and it has to be robust against sort of changes to the underlying schemas. So I think in this case I would probably want something explicit, and in general I think. You probably want to be careful sort of what you actually exposed to external clients to sort of free like queries that people execute. But there are various intermediate states where you might have persisted queries, or you might use a query to like implement an MCP tool. And in all those cases, like that extra power can be very useful.
Earlier on you said that namespacing shouldn't be used to avoid kind of overall schema design, but then later on that namespacing could be used to let slices of schemas evolve independently. Is that not kind of at odds?
It is. I mean, there's definitely a tension. I think what I would say here is like it shouldn't be sort of an easy excuse to sort of get you out of the need for schema design altogether. And you want to be really careful in sort of what the basis for these distinctions is. So I don't think it should be based on like the current technologies you're using, or like the microservices you've broken up something in. Ideally, it would be based on your domain model. Like there would be some sort of long-lasting reason for making that separation. Sometimes that corresponds with organizational boundaries. Sometimes it doesn't, and you may have to sort of make some pragmatic choices there. But I think like the most important point here is like namespacing shouldn't be a way out of schema design.
What's your take? Thanks. What's your take on the namespaces if you have, for example, 70 subgraph? That you should always do namespacing per subgraph, or just by default, or not?
I mean, that's a good question. I would definitely not namespace by subgraph. I think subgraphs are sort of units of composition that often cross boundaries. And in general, I think there's a many-to-many relationship here. So a subgraph may actually contribute to multiple namespaces, and a namespace is usually built up out of the contributions of multiple subgraphs. I think the namespacing by default would be an example of like taking the current, sort of the way your system has currently been broken up and encoding that into the schema. And that's something I would argue against.
You have one example where you show like in the query, you like, oh, this field is like greater than 10. That would be true or false. I like this idea. It's very flexible. It reminds me a little bit of SQL. At the same time, I feel there is some concerns about like you're kind of putting business logic in the query, and it could be problematic. So imagine you have like 10 views. You have, oh, is in stock is greater than 10, and then you change in one, you don't change in the other. Yep. Then it becomes a little messy. But at the same time, like in an agentic world, I think like this flexibility would be very nice. So I don't know, what do you think? I just want your take on this. Is like, should we make clients more customizable? Now we are going to agentic, or should we keep that, oh, clients should be dumb, and keep that like famous sentence? What's your take on this?
Yeah, I mean, I think you're entirely right there. I think that there are different types of clients, and maybe agentic development will sort of change the needs here. I think for like this is obviously just like the in stock as an example, and I think you're right that I mean maybe it's simple enough so the duplication doesn't matter and you don't really see it changing. But I think it's also something that you'll likely want to put in your schema, so it can actually be reused by all your different clients, and the implementation can change without like affecting your clients. I would say sort of that extreme flexibility where you have like an expression language as part of your query, I would probably save that for persisted queries and like MCP tool definitions, things that like you still have a single source of truth for that. You might even have an opportunity, for instance, for persisted queries to change the implementation without affecting the users of that query. On the other hand, like I don't really see any issue with putting it in the schema. I know that isn't what you were asking, but that might be something other people wonder about. Like, should business logic be part of your schema? I actually think there's a benefit to making it part of the schema definition here, because the alternative is that it lives somewhere in code in one of your subgraphs, and that's actually less transparent. These expressions also allow a query planner, for instance, to reason about relationships and perhaps may result in more efficient query plans. Yeah.
With respect to that point, I think you have to distinguish declarative expressions of business logic versus where it belongs. I mean, I think that in Viaduct, we used to have a whole bunch of declarative implementation stuff kind of in the schema. It just got messy. So I think it might make sense to be able to express declaratively a whole bunch of business logic, but that experience suggests the schema itself, you know, what you see in when you go to your schema explorer, it shouldn't be there.
Or at the very least, it should, like, there needs to be like heavy IDE support or something like that to like help make it, you know, like hide the implementation details when you don't want to look at the implementation details and like show them when you do or something like that. You know what I mean? Like,
Definitely, yeah.
which, you know, just not a good willingness today after that.
And just to be clear, I don't think this should be sort of a general computational language, it's expression language. I would compare it to like a SQL view, for instance. Like it's a very, there's a declarative specification, there's a very clear relationship between like the source of the data and the derived shape. I would definitely be careful about like doing too much in that language. Any more questions? I think we're...
How do you foresee, I guess, the autonomy of kind of individual teams that would develop subgraphs being affected by the introduction of namespaces? Like, who do you think would, I guess, manage those namespaces?
Yeah, I mean, that's a good question. I think ultimately those are all decisions that depend on like your organizational structure and your workflows. I can definitely imagine sort of creating a new namespace to be something that requires like some level of approval. But once you have a namespace, like that gives a lot more autonomy to individual teams. So what we sometimes hear today is sort of understandably like platform teams are protective of their schema. And that makes it difficult for individual like subgraph teams or product teams to actually get the API they want or need. So my hope would be that a mechanism like this would actually empower like both those subgraph developers and the product teams, the API consumers, to more incrementally sort of get to the API they want and need. All right. Yeah, I think it's time for lunch then. If you have any more questions or ideas, come look me up.